Hey everyone, so we have another probability counting principle problem. It's a very short one. You're going to like this one, and it will start immediately after this. So it says, given the digits 3, 4, 5, 6, 7, 8, and 9, calculate how many unique 5-digit codes that can be formed using the above digits if, number 1, the digits may be repeated, then number 2, the bits may not be repeated, then number 2 says how many unique 3-digit codes can be formed using the above digits if 2.1 the digits may be repeated, the code is greater than 400 but less than 600, the code is divisible by 5. Okay, so let's start with the first one. They're saying digits may be repeated, so we're going to need some placeholders. Let's use these boxes as placeholders for our 5-digit code, and then we'll analyze each position, which of the digits are allowed to be there. And then in the boxes is not the actual code we're generating, it's actually the number of possibilities that each position has. So we're going to see how many numbers are allowed to be in each of the positions and follow the conditions that we are given. So let's see the first position. We see that since the digits may be repeated, all the digits are a possibility for this place. So it means we will have a 7 here. The 7 represents the number of digits that we have here. So if we had 10 digits, we will put a 10. If we had 5, we'll put a 5 here. So we have 7 that can be used. So that's why we have a 7. And same goes for the second position. Again, repetition is allowed. So 7 possibilities again here. Third position is same as that. All the digits are allowed. So it means we have a 7 here. So I'm sure you can see now that this is going to end up being all 7s. And the answer will be simply multiplying these 7s together. And that gives us 7 to the exponent 5, which is 16,807. That was easy. Okay, let's see what happens when repetition is not allowed. 1.2. So 1.2, they're saying no repetition allowed. So let's have those placeholders again. And in the first position, since we have not used any of the 7, it means the first position still all of the digits are allowed to be there. Okay, so we have 7 here. But now when we come to the second position, it's all of the digits except the one that was used here. Now you must understand that the 7 that we have here is not the 7 that is over here. The 7 that we have here is the number of possibilities that we have. So these could have been letters, and there could have been 7 letters here that we are forming. We are forming a password. And then we would still have a 7 here if there were 7 letters. So that's something that you need to understand. These numbers are not the numbers that we are looking at here. They are the number of options that we have for each position. So the first position had 7 options, And then the second position now, it's all of those 7 options except the one that is used here. We don't know which one was used here. It could be any of them. It could be a 9, it could be a 3, it could be whatever. So it means we have only 6 of them left to use here. Okay, I'm sure you can see the pattern now. So in this third position, we will have all the digits to use except for these 2 that have been used here. Again, I'm emphasizing that the 6 and the 7 are not these 6 and 7 here. So I'm just saying that whichever number that we used for the first position and the second position can no longer be used here. So which means we have only 5 of them left to use. And then this goes on like that. And then we will have a 4 here. Again, we have all of them except the first 4 here. And then it means we'll have a 3 here. Then again, we just multiply these numbers. And multiplying these numbers gives us 2520. Nice. Now, the second part of the question says, now we're forming a 3-digit code from the same numbers or same digits. And so for that, we will need, okay, before we start with the placeholders, the conditions that we are given for this 3-digit code that we're making is that digits may be repeated, so a repetition is allowed, but the code that we must create must be a number that is between these numbers. Must be greater than 400 and less than 600, and it must be divisible by 5. Okay, so I'm going to list the possibility or the possible numbers that we can put here. Then we'll count how many they are and put the number here. So first position, do you realize that only these 2 can be here? So a 4 is allowed here because we need a number between 400 and 600. A 5 is allowed. It's going to make this number between 400 and 500 again. Okay. Then we needn't worry about the code being exactly 400 because we do know that we don't have zeros in our selection of numbers here. So we are sure that whatever code is going to be here is going to be strictly greater than 400. Okay, so we have 2 things that are possible here. We cannot have a 7 here, we cannot have an 8, we cannot have a 3. So these are the only 2, and for that reason we put a 2 here. Then now we come to this position. In this position, repetition is allowed, and it seems that all these numbers or these digits are allowed here. So it means we will have a 7 here. So the middle number does not affect any of the conditions that we have. Then in the last position, only a 5 is allowed here because we need this whole number to be divisible by 5. And we know that a number is only divisible by 5 if it ends with a 0 or a 5. But we don't have a 0 here to use. So that means 5 is the only option we have. So that means we have only one position here. Then we multiply those and then they give us 14. And that's the end of that question. Nice and short. I hope you liked it. Please like and subscribe and post comments in the section below and tell me what to do next, and I'll see you in the next one.